welcome and thank you for joining. Let's take a look at a group of exponential and logarithmic equations. So I gotta warn you though, this set of equations is at a higher, more enriched level, but they're so much fun to solve. So we're gonna start off with the first one. So first we're gonna read the equation and we have to make sure we understand where x is applied to. So 16 to the power of x. So what that means is that only number 16 or base 16 is raised to the power of x. So similarly, 81 to the power of x. So the power of x is applied to the base 81. Number 2 is simply a coefficient of the term and equals 5 times 36 to the power of x. So basically, when we solve exponential equations, we look for common bases. And as you can see in here, the bases in every exponential term is different or are different. So how do we approach this? So in this case, what we're going to try to do is minimize the number of bases. So if the bases are 16, 81, and 36, and you probably notice that these are kind of perfect powers. So this is 2 to the power 4, this is 3 to the power 4, and here we have 36, which is 6 to the power of 2. So to minimize the number of bases, I will try to divide every term in the equation by one of the exponential numbers. It doesn't really matter which one you choose. I am going to go for 36 this time and see what happens. But if you understand how this works, then you should be able to solve the problem in more ways, more possible ways on your own. So if we divide it by 36 to the power of x, every term in the equation, both sides always, then we have created an equation that will have the same solutions. So why would you do this? Well, first of all, we want to eliminate or to minimize the number of bases. And secondly, we want to regroup things, or we want to change the face of the equation, and hopefully and probably we'll see something that they would have in common. So on the left side, we have 16 to the power of x, 36 to the power of x. So you see that there are two terms to the power of x. So what we can do is write this power of x in here with a common base 16 over 36. And I will explain why and how we can do this. Now remember that if we have a over b to the power of x, then x will apply to both numerator and denominator. So that's what gives us a to the x over b to the x. So similar to this, if we have a to the x over b to the x, then we can go back to a over b to the power of x. So let's move on with the next term. So you probably figured out already we're doing something similar here. So we have the power of x, and the base will be 81 over 36. And on the right side of the equation now we have just the number 5. So let's simplify each base. As you can see, they are reducible. So 16 over 36, so they will have a common factor of 4. So 16 over 4 is 4, 36 over 4 is 9. So we have 4 over 9 to the power of x, and then plus 2. So let's take a look at this. So 81, well, it has a factor of 9. 36 has a factor of 9. So we can divide both by 9 or reduce the fraction by 9. So that will give 9 over 4 to the power of x equals 5. So as you can see in here, not only we reduce the bases, but we notice that there is a pattern in here. And remember that our goal is to make the bases the same. So we either can make the 4 over 9 into 9 over 4, or we can make 9 over 4 into 4 over 9. So this time what I'm going to do is try to change 4 over 9 into 9 over 4. And I know I can easily do this by simply giving it a power of -1. That's what reciprocates the fraction. And we still have the power of x outside it. So I'm taking the steps slowly here. And then plus 2, then 9 over 4 to the power of x. And I'm going to bring 5 to the left side of the equation because I notice this is not a simple linear exponential equation. So next, what we can do is simplify. And again, I'm taking the steps slowly. You don't have to show all the steps the way I am right now. So 9 over 4 to the power of negative x plus 2, 9 over 4 to the power of x minus 5 equals 0. Now, for some people, it would be easier to envision the equation a little bit differently. So instead of having a fraction in the base, you can let that fraction in the base be represented by some letter of the alphabet. And I'm going to choose letter A in this case. And I would say that if I let 9 over 4 to equal some number a, then my equation would look probably a little bit friendlier. So we would have 3a to the power negative x plus 2a to the power of x, and then minus 5 equals 0. And I'm going to make that a the same color as 9 over 4 that I had here, so we can see it better. So I bet that you've seen and you've solved equations in this form. And what we have done in the past was convert the powers to a positive. And that means that in the next step, we have 3 over a to the power of x plus 2a power of x minus 5 equals 0. So we will multiply every term by a to the power of x. And the reason why we want to do this is so that we won't have fractions in the denominator. Now, normally, and especially when we already have fancy terms like an exponential term, we don't want to have fractions as well, or denominators, because it just complicates it, right? So we're multiplying by a to the x every single term. So a to the x goes here, a to x will go here as well. Okay, so I can afford a little bit more room in here. And a to the x will multiply the very last term, so the 5. Let's see what we get now. The fun part in solving equations is simplifying. So whenever we transform them, when we simplify, I look with that anticipation that you're going to see something exciting, something new, something that will make you think about, the next step, or maybe you have a right to the final answer. So let's see what we get here. So a to the x and a to the x simplify. That would leave us with number 3 here. Now, notice that you have 2a to the x times a to the x. That will make 2, and then a will be to the power of, this is simple product rule or product law, x plus x, which would be equal to 2x, and then minus 5a to the power of x. Now, take another look at this equation. So see what I meant by the excitement that we have whenever we simplify an equation. So you probably notice that this is an exponential equation still, but we notice that this is a quadratic exponential equation. So to make it look like quadratic a little bit better, so what we're going to do is bring the power of 2x term first. So we have 2, and I'm not going to write a to the 2x the way it is. So I'm going to write it as a to the x squared. And then minus 5, a to the power of x, and then plus 3. Voila. So this would be a quadratic equation, 2 times something squared minus 5 times that something plus 3 equals 0. So we can solve this by factoring, or we can solve it by using the quadratic formula. And in this case, I am going to choose, let's see what we can do here. We can do factoring because, as you can see, we can find 2 numbers that multiply to 6 and add to a negative 5. So, which means that this must be factorable. So we're going to say that the factors, which will be in binomial form, so must both have a to the x to start with, and one of them will have to have a coefficient of 2 and the other coefficient of 1, because that's what gives us 2a to the power of x squared. I'm only explaining how to factor this because it's always a little bit more confusing when we have quadratics, or when we're factoring a quadratic that has exponential terms in it. But it's not too difficult. Just remember that we're only working with the coefficients, right? So it's only the coefficients that will help us, or will help determine the factors of it. So 2 and 1 are the factors that will give a 2 here. And here we have to place two numbers that multiply to a positive 3. Now remember that the sum here is negative. And with the product positive means that both numbers must have been negative. And there is only one way we can break 3 down into two negative factors. So either negative 3, negative 1, or negative 1, negative 3. So, negative 1, negative 3. So let's check and see which one works. Since we're at it, so that would be 2a to the power of x positive. This would be positive 3. That's pretty good. And then we will have, negative 1, negative 3 here. So we have 2a to the power of x squared minus 6a to the power of x minus 1. Oh, that would give us minus 7. So let's try the other arrangement. So let's place the numbers 3 and negative 1 this way. Let's see what we get. So we have negative 2, negative 3, which will give negative 5. So voila, here we are. We have to make now each factor equal to 0. So 2a to the power of x minus 3 equals 0, which means that a to the power of x would be equal to, remember, negative 3 will go to the right side, so positive 3, divided by 2. So we got a to the power of x, and I'm going to leave it here for the moment being, and we'll move on to the other factor. We're not done solving this equation. So a to the x equals 1. Now remember that a is a new variable that we brought in. It replaced 9 over 4. So if you want to solve for x, we need to bring 9 over 4 in and see what we get. So 9 over 4 to the power of x is 3 over 2. Or we're going to say 9 over 4 to the power of x equals 1. So there are different ways of solving this very simple exponential equations. And the more straightforward way would be by simply equating the bases. As you can see here, we have 9 over 4 that can be written as 3 over 2 squared to the power of x equals 3 over 2. And if you want to imagine or see the power a little better, so you can write a power of 1 for 3 over 2. So once the bases are exact same, 3 over 2, it means that the powers or the exponents must be equal. So the exponents in this case are 2x on the left side and 1 on the right side, which tells us that x must have been 1 over 2. Now, for the other equation, 9 over 4 to the power of x equals 1, we can rewrite it as 9 over 4 to the power of x equals 9 over 4 to the power of, guess, 0. Any number to the power of 0 will create a 1 or makes 1. So that tells us that since the bases are the same, obviously 9 over 4 here, so that means that the powers then must be equal. So x must be equal to 0. So we obtain two solutions in here. X equals 1 over 2 or x equals 0. And let's take a look now at our solution. So if you want to check and see if it works, what you want to do is bring the two x values that you obtained into the equation and see if the left and the right sides would equal each other. So I'm going to try to do this with a fancy red color. And let me make this a little thinner. So if we have 1 over 2 for the power, it basically means the square root of that number. So to simplify the calculations, I would say 3 square root of 16, that would be 4, plus 2 square root of 89, which is 9, must equal 5 square root of 36, which is 6. So 3 over 4 will be 12, and 2 times 9 is 18. So 12 plus 18 is equal to 30. And 5 times 6 equals 30. So 1 over 2 is one of the solutions. And obviously the other solution will be x equals 0, because as you can see in this case, if x equals 0, all these exponential terms will turn into a 1. So therefore, we're going to have 3 plus 2 equals 5. So both solutions work, and this is, and they are x to the power x equals 1 over 2 and x equals 0. And I hope you found this these explanations useful, and I hope you found this exercise fun. Bye for now.